Okay, let's look at solving log equations. These are simply equations that have logs in them, and we want to keep in mind our log properties as we go about doing this because it's going to make our life a lot easier because it'll enable us to simplify. So if we look at this example here, if we look at the right hand side, we notice that there is a sum of two logs. So we can rewrite that right hand side as the natural log of x times x minus 5. So notice how we're going from seeing two logs in the problem with that addition sign separating them to a single log. And remember, when we do that, we write it as a single log, we really have to convert it to multiplication, all right, of the two parts that we're taking the log of. Well, at this point, notice how we have the natural log of the entire left-hand side and then equals the natural log of the entire right-hand side. So because we have the natural log of both parts, we might as well not take the natural log of anything. So we can de-log it, as we say, and then from there, we're just left with, if we distribute, we're left with x squared minus 5x on that side. Since this is a quadratic, let's bring everything over to one side. So if I were to add over x, I would have minus 4x, and then I'm going to subtract over my 12 so that it's equal to 0. This is factorable. So we're going to have x plus 2 and x minus 6. From there, we're going to get negative 2, and we're going to get positive 6. But it's very easy to think that you're done, to stop right there, and to just circle both of them and move on. Well, we have to check for extraneous roots. Let's write that down. So extraneous roots are roots or answers that we get that do not check out. So what we have to do is we need to go back to our original equation here, and we need to plug in both of these values to make sure that we're not taking the log of 0 or of a negative number. That's what's going to happen here if we end up rejecting one of these. So if I first drop in a 6, I'd have the natural log of 12 minus 6, no problem there. Over here I'd have the natural log of 6, and over here the natural log of 1 after I drop in 6. That's okay, so this is an acceptable answer. Now, negative 2, if I drop in a negative 2 in this first piece, that'll become 12 plus 2. That's fine. But notice right here, we have the natural log of x. If I plug in negative 2, we're taking the natural log of a negative number. Okay? So we can't do that. So what that means is that negative 2 piece we are going to reject. So in the end, our only solution is 6. Okay? So always be on the lookout for what we call extraneous roots. Look at the prefix extra, right? They're extra roots, okay? And usually this is applicable to examples where you have logs in your original equation, and if something's not going to check out, it means you're going to be taking the log of 0 or a negative number, which we know is outside of the domain for log. So be on the lookout for that. Okay, here's a log equation where notice there's only a single log in the problem, so we're not going to be able to delog it like we did in the previous problem. So we still want to get rid of this log, but the way we're going to do that is we're going to convert it from log form into exponential form. Recall, this is where we said we can draw these arrows and rewrite this as 5 cubed equals x minus 2. Well, that's 125 equals x minus 2. So x would be 127. And if we were to take that answer and plug it back into the original, right here for x, all right, we would not be taking the log of a negative number, so we're good to go, no extraneous roots. That would be our solution. All right, one more example here, and in this example we are looking to find exact solutions. So that implies that you're not going to have nice integer values. We don't want to express our final answers as decimals, okay? So we want to just keep that in mind. So notice we have log base 5s everywhere. And if we look at this left-hand side, we are subtracting 2 log base 5 terms. So we can consolidate this or shorten this by turning it into a quotient where you have x plus 3 and then x plus 1 divided like that. Again, we're using a log property that says if we are subtracting 2 logs, turn it into the log of a quotient of those two. And then we have log base 5 of x plus 2. Well, we can delog this since we have log base 5 of the entire left side and right side. So from there, we're just left with the inside pieces. And then we're going to have to put this over 1 and cross multiply, okay, to solve for x. So when we do that, when we go this way, we're going to have x squared. You're going to have a 1x plus a 2x. That's going to give you 3x's total, and then plus 2. And when you go the other way, you just have that x plus 3. Well, this is a quadratic, so let's get everything on one side, make it equal to 0. So I subtracted over my x. I'm going to subtract over that 3. That's going to give me a minus 1. Okay. So from here, this is not factorable. Okay. So we could either solve by doing complete the square. It would not be a bad option since this b term is an even number. It gets kind of messy if it's an odd number. But we could also use the quadratic formula. So I'm going to do that. Okay, so we have negative b, which would be negative 2, plus or minus the square root of b squared. So 2 squared is 4. Minus 4 times the a, it's a 4. The a is 1, and the c value is negative 1. And this is all over 2 times a, and again the a value is 1. So let's clean this up. We have negative 2 plus or minus. We see 2 negatives here, okay, so that's going to end up giving us 4 plus 4. So that's a square root of 8 all over 2. So we have negative 2 plus or minus. Now when you break down radical 8, that's radical 4 times radical 2, which is 2 radical 2. From there, we can divide out these 2's and replace them with 1's. So we have x equals negative 1 plus or minus the square root of 2. So remember, we need to be checking for extraneous roots. So let's first break this apart. We have negative 1 plus a radical 2, and we have negative 1 minus a radical 2. So we need to figure out if we need to reject any of these. And let's suppose we are not allowed to use a calculator. So if we look at this first one here, well, you need to know that radical 2 is a little bit bigger than 1, right? Of course, radical 1 is just 1, so radical 2 is something a little bit bigger than 1. So if you take something a little bit bigger than 1 and subtract 1, we're looking at a positive number. So if we take a positive number and plug it into all 3 of these pieces, we're going to have a positive value. So this root is okay. Now, with our other one here, if you look at negative 1 minus radical 2, you're looking at something that is negative 2 point whatever. So it's smaller than negative 2. So if you look at either this portion or even this portion, something around negative 2.4, if you were to plug it into either this one or this one, right, there's going to be a problem. You end up taking a log of a negative. So this one we need to reject. So our only solution here is negative 1 plus radical 2, which, by the way, could also be expressed as radical 2 minus 1. Okay?